Good day, my dear children. Today we will start the next topic in physics, the clue of which is in the slide presented before you. If you are the light, you cast away the darkness. Rightly said, the topic we are going to discuss in the next few slides is about light. Moving on, what are the objectives of this session? We will learn what is light, about the dual nature of light, what are the important properties of light, and certain basics about image formation by substances or objects. Now, when we talk about light, the question comes, it's been confusing to people all over the world for many years now. What exactly is light? As on date, we all know and understand that light is a type of wave that has a particular energy associated with it. There are various sources of light in the universe. Some objects emit light on their own and they are called self-luminous objects, like the sun. Some other objects reflect the light that fall on them. They are called non-luminous objects, which includes all of us. We don't give out light on our own. A light ray is a narrow beam of light that travels in a straight line. You could compare this with the atoms, right? All substances are made of building blocks called atoms. Similarly, when we say light, it is made up of individual units called light rays. Photon is the basic unit of light, right? Now, photon is a carrier of electromagnetic radiation and it contains all wavelengths. We've studied about wavelengths in sound chapter in grade 9. Light also has a wavelength associated with it, which we will be studying further. A photon is an absolutely weightless particle and is actually a bundle of electromagnetic energy, which means it has electromagnetism present in it, and light is made up of millions of photons. We talk about the dual nature of light. As we all know, dual means two. Okay. Now, how does light show double nature? And what are the two natures? As you can see here, light shows properties of particles and waves. Okay? Now, how can you prove it shows both the properties? Suppose you shine light from a light source. Here it is a torch, right? And you place a barrier. Barrier means something which obstructs the path of the light. What will happen is, in some cases, you will not be able to see the light after the barrier, which means the particles are not able to travel beyond the barrier. In this way, light demonstrates particulate nature, which means the light travels in straight path. Okay, and if you put a barrier in between, the path gets blocked and you don't see light beyond it. Okay. The second is the wave nature of light. Let me demonstrate this in a very simple manner. Suppose this is your room, okay, and you have the room door here. And inside your room there is no light that is switched on. It is absolutely dark. But outside, maybe in the living room, there is a source of light. Your door is closed 3/4, which means it is tilted at an angle. It's not completely closed. So what will you observe? You will observe that the light from the light source in the other room seems to bend at the end of the door where it is open, and the light seeps into your room. Seeps means it comes inside your room and it appears as though the light ray has bent wherever it got space and it has come inside the room. So this can happen only when the light is traveling as a wave, right? Because waves have troughs and crests. So these two prove that light exhibits a dual nature. It can behave like a particle, at the same time it can behave like a wave. So going back to the previous slide, what did we discuss? We discussed that light is made of particles called photons, which are electromagnetic in nature. So that is particulate nature and wave nature at the same time. Going over to the next slide. What are the main properties of light we intend to study further in the chapter? Number one is reflection, which is demonstrated here. Reflection, we all know. Whenever you look into a mirror, right, you see yourself there. You keep, suppose, this marker in front of the mirror, you will see the marker in the mirror. That's called reflection, right? Next is refraction, which is here. What do you observe in this? You observe that the light seems to bend when it goes from one medium. This is called as medium. Say suppose this is air and this is a slab of glass, right? And again there is air this side. So when light goes from air and it falls on the glass slab, the light seems to bend. And when it comes out, again it seems to bend. So this bending of light rays, when it goes from one medium to another, is called as refraction. The third is dispersion. This is a very small experiment which all of you would have done. You know, if you pass white light through a prism, a glass prism, you will observe that the white light splits into 7 colors, which you would have learned in your younger classes as Vibgyor. Violet, indigo, blue, green, yellow, orange and red. So this splitting of white light into its constituent 7 colors is called as dispersion. The last property you will learn is total internal reflection. The term itself gives you a clue. There is reflection taking place, but it is occurring inside a particular medium and it is complete, like what you are seeing here. This effect you see inside raindrops. When the sunlight falls on a raindrop which is in the air, it undergoes total internal reflection, meaning the bubble adds the various faces of the bubble reflect the light ray from the sun multiple times. So the 4 main properties of light you will be learning are reflection, refraction, dispersion and total internal reflection. We'll now go ahead and see how do we actually see objects. Right? You're looking at me, I am looking at the camera now. So how are we able to see things around us? Before we go to the explanation of this slide, let's quickly recap that we learned about 2 terminologies, luminous objects and non-luminous objects. Now what are luminous objects? Luminous objects are things that give out light on their own. For example, the sun. The sun produces its own light. Non-luminous objects are exactly the opposite. Non-luminous objects do not produce their own light. Now then the question is, how can we see the non-luminous objects if they don't give out light? What do non-luminous objects do is what's shown here, right? In this picture, you can see the sun. You can see an object, and this is maybe any one of us who is standing here and looking at the object. The light from the sun falls on the non-luminous object. What does this object do? It absorbs certain colors of the white light and it reflects the rest back. Okay? So whatever light is reflected reaches our eyes, and that way we are able to see this object. Now another interesting thing, I'm sure many of you must be knowing it by now. Okay, How do you know that this dupatta that I am wearing is orange in color? Because this particular piece of cloth is absorbing all the colors from white light falling on it, but it is reflecting orange. Orange is not being taken up by this piece of cloth. So whichever light color is sent back, the object will appear to be that color, right? How do I see that the body of the marker is white? Very good, because it is not absorbing any color. It is giving back the white light that is falling on it, right? So the light from a luminous object falls on another object which may be non-luminous, and the light that is reflected from this is perceived by our eyes. And we've already learned we have rods and cones in our eyes which help us detect the intensity of light and color of light. How do you see light sources? Light travels from the source to our eye, okay? And we can see sources in a dark room. I'm sure some of you might be having those radium stickers fitted to the ceiling of your bedrooms. So even when you switch off all the other light sources, you will see them glowing in the dark. And give me another example from nature of a self-luminous source. Very good, fireflies. Interestingly, a photographer, she's only 23 years old, has won the Best Photographer Award in the Animal Wildlife category because she captured the activity of fireflies around a tree. And fireflies appear so beautiful because they are luminous. They produce their own light. I'm sure whatever we discussed in this session is clear to all of you. Thank you so much.